Oh my god. Y'all are such sheep. Alright, welcome to my little presentation. I'm going to be talking about this this Linux privilege escalation technique using GTFO bins and the SUID bit, which is this little bit right there. So, if you don't know who I am, how long have you been coming to research? What's going on? So here's the basic rundown for today. I'm going to be explaining what and why GTFO bins are, SUID bit, why is this important to you, what could it be used in, going over basic Linux permissions with the specific SUID bit, a bunch of different binaries where this is applicable, and some more neat, interesting binaries that could be cool. Little disclaimer, a lot of this stuff is based off of the Pone College program misuse lab, so there'll be a lot of spoilers for that lab. So if you're interested in that, close your ears. So let's take a situation where you're thinking about where you're pen testing something. So you get into hypothetically a server running Docker, and you find a way to break out of that container, and then you end up being the Docker user. So if it's following the principle of least privilege, that Docker user should only have sudo privileges to run Docker, because Docker needs sudo to run. Say you can look up on the GTFO bins website. I will have to reshare this, but if you actually go to the website yourself, you can look up GTFO bins, and then we can go through it right now. So this is basically what the website looks like. It has a curated list of a bunch of Unix binaries that can be used to escalate privileges. So if we actually look up Docker, we can see that it has shell, file write, file read, SUID, and sudo functionality to it. So if we go further, we can check that we can actually break out of this Docker user and get a root shell. This is actually a kind of cool technique where Docker, see Docker run right here, if you can't see it, it's Docker run tag V, which deals with binding volumes. So if you remove it after interactive shell with Alpine container, you can set the permissions for your interactive shell with that container to the shell of the host system, which allows you to get a root shell in the system, which I think is quite interesting. So back to the thingies. Whoop-pow. So that's a pen test situation where you can actually use GTFO bins. And we're back to normal. Yeah. So this can also be used as a certain red team tool. This is kind of a low-hanging fruit situation where you can enable the SUID bit on some random binary on some blue teamer's box, and it basically allows you for privilege escalation through that binary. So if Docker has the SUID bit, you can get a root shell on a box if you already have initial access. It's kind of a quick and not so discrete thing. If a blue teamer has like a tool to scan through every binary, they could find the SUID bit on it being active, and they could automatically get rid of it. But if someone's not looking for it, or the binary is symlinked, so it shows like the symlink when you're looking through the directory instead of the actual permissions of the binary itself, it could be a little hidden, and you wouldn't see it at first sight. Next up is an IR situation. So you are blue teaming, and what? You notice an SUID bit? Dog, you messed up. You got to figure that. You got to figure that out because someone could be privilege escalating on the box. Next,
can you explain what an SUID is?
Oh, let me get to that a little later. We'll be going over that. Did you not read the agenda?
No.
So yeah, we're going to be going over basic Linux permissions. This is stuff that you'll cover in Task Auto, but we're going to go through a little bit of a rundown. So you have the user group for the permissions on anything in Linux. Everything is a file, and all these permissions describe who has access to it. So for the user, you have 7, which allows read, write, and execute capabilities. The group only can read and execute. Same with everybody else, and those are listed with 755. So the SUID bit actually resides right in the executable part of the user binary. So if you wanted to do this on your own computer, you can actually run this command, and it'll enable the SUID bit for the cat binary, which just allows you to read files. Same with this. It's just another way of adding the S to the user group part of the binary, which cat just finds where your binary is located on your system. It's usually /user/bin, yada yada. This is an example of something that was just on my desktop. I don't know what it is. It's kind of just hanging out there. But as you can see, it has the permissions for 644, which read, write, read, read. And if we compare that binary to that cat binary that we gave its privileges, that SUID bit, it shows an S right where that X is supposed to be. So it's read, write, SUID. And what this SUID bit allows you to do is if you execute it as any user, you're actually executing it as the file owner. So that's why these binaries are so important, because root is usually owning a lot of these binaries on your system. And so with that there, it allows you to execute a binary as root. You know, a little scary. So hopefully that answered your question. So we're going to go over some common binaries. So we have more, which basically allows you to print out contents of your file. I have a very secret test.py file on my computer, and it basically prints it out. So if you try to do this without the SUID bit, you'll get, oh, you cannot open the flag for reading, permission denied. If we check again, oh, we didn't have the SUID bit set. If I gave it the permissions in another shell, and the SUID bit is there now. So if you just ignore the flag, it basically just prints that RITSEC content. Another common binary, which is pre-installed on like mostly every Linux system, is just the base64 binary, which allows you to encode things in base64. So you get this hello world, this garble of text right there. So again, if we check, we don't have it. We base64 file, which will encode the file. It doesn't work. I give it permissions, and now it allows us. It gives us this output with the flag equals. Just a little neat thing. You can just pipe it back into itself and decrypt it, and that allows you to get the flag. And if we check, boom, SUID bit is set. This, the flag.txt file could be any file. It could be your Etsy password. It could be your Etsy shadow. It's an arbitrary file read on any file on disk. So it's kind of bad, but in normal CTF sense, you'll be looking for a flag. Another binary is watch, which watch allows you to watch any command that is run into it. So you could watch psaux. There's other programs that do this, like top or htop, which progressively look over the system and check what binaries are running on it like continuously. psaux will just run once and print everything out. So as you can see, there's the root PID taking up 0.1% of my memory. So if we check it has yes, we tap a flag normally, doesn't work. But if we do watch cat, it still doesn't work, because watch is a little special. Watch normally executes the command with sh-tac-c, which basically just throws your command into the shell. So by passing the tac-x flag, it'll pass it to exec instead of sh-tac-c, which allows you to bypass sh realizing that you're not root and allowing you to set the flag. And this is the phone call stuff I was talking about. So another common binary is awk. Any like Python, Perl, anything could be given this SUID bit. So with a programming language like awk, basically giving you permissions, you can just program anything into it. So right now I'm just printing out my test.txt file. I have a weird amount of files on my system that are just random text from like whatever I was doing at the time. But if you actually take awk, check as the SUID bit, the simplest awk program you'll probably ever do is just awk // and then the file, and it'll just print out arbitrary file reads. So now for some more interesting binaries, we have wget. If you're thinking like, what the heck is wget? I do this and I download the index.html for Google. which is quite useless. But if you check, you get the SUID bit, and if you actually run wget cat I, it'll print out like the weird URL encoding of the file and weird like lowercase version of it, which isn't very helpful with getting the exact contents of the file. There's another technique which is listed on GTFO bins, which actually makes a temporary file, it's mktemp, just throws a temp file. You assign it to a variable, you get that file, execute permissions. You actually throw in like a shebang with bin sh, which is just shell, which gives you shell access. We use wget to look for the password within the file, so a 0 at the end, and it gives us a separate shell. It basically allows you to break out of the binary. Another way to do this, which I couldn't recreate in the time it took to make the presentation, but if you have a server, a Python server running that allows file uploads to it, you can actually take the wget binary, grab the file that you want, upload it using like whatever put to the server, and it allows the Python server to get that file and allows it to have it on that system. So there's a command like python taxi http.server, which allows you to spin up a very rudimentary server. There's a lot of resources online to do that. Another interesting binary is GCC. I mean, you're thinking, what? I just use this to compile my bad C programs that don't let me pass 201. But there's actually a little neat thing. GCC is one of the most complicated programs ever. If you run man on it, it's just like garbage of text. I was looking through this binary, I was like, what is happening? But there's this little thing where you just use the @ symbol in a file, and it basically errors and just dumps whatever it errored on because it's not understanding the file. Another way to be able to get an arbitrary read is passing this command in. So GCC allows you a lot of specifiers. So TACX allows you to specify what language you want. I don't know why it's X, but we give it C. I don't know why, if you just specify C, you're writing C. I think that's the default though. And TAC-E is for end post-processing, and will only read the file and dump the source code, which is the flag, instead of actually going through and compiling the rest of the program. It's just weird, neat things in every different binary on your system. If you're looking through GTFO bins, there's just so many different binaries that why does this give me capabilities to execute other commands on my system? Why does it give me the ability to write to a file when I shouldn't? I think my favorite one of these binaries, this is going to be a spoiler for the final level of that phone calls module I was talking about, is SSH keygen. What? You're just generating keys for SSH connections. It's very simple, very simple. But deep down in the dark man pages is TACD. This basically just allows you to load a shared library. I don't know if any of you guys know what a shared library is. It's basically a compiled C code. C, which allows you to do anything on your system. So this is a very bad problem. It allows you to just download the public keys that are within that file. So if we do, so this is a little test. This is gonna be a little audience participation. I compiled two files, making them shared objects, as they outputted the name, and all these other weird format parameters. SSH, yeah, that's C, and SSH, no, that's C. One of them works, and you're gonna have to solve the reason why one doesn't. So, oh yeah, I do that. So we have the file SSH no.c. Standard includes standard. You have the main, you have file char. We open the file, read to the end, print everything, close it. It's beautiful. So let's pass it into SSH keygen and see what happens. It doesn't work. We pass it in with that TACD, a flag, and it says that lib2so, the name of the library, doesn't contain an expected string cget function list. So can anyone tell me why this doesn't work? Because it's looking and it can't read any public keys. Does anyone know why or what they would do to change the file to have this work? Sure. Correct. You got to implement the function that it's looking for. This was just oh wait, I just got to do this when I was doing this for the first time. So if you actually just change main to get function list, SSH keygen is just going to call that function and dump the file and save all for you too. So it just explains, just does it all for you. It's beautiful. Why does SSH keygen just allow you any shared library? That's so weird. That's so cool. I mean that's the last binary they had. There's a lot of cool things that like you can further go along with this. Some of the resources I used were for Cone College that provided a lot of the content that was going off there. There's I don't know how to pronounce this. This basically like a precursor to Cone College. It has a lot of good information. If you don't think you're ready enough yet, thank you Cipriano for that. As well as GTFO bins, has that list of all the binaries that we looked at earlier. We have like man7.org and linuxspy.net, which are basically just a way to look at the man pages with HTML instead of just in your terminal, which is a little better for a control F thing. And then another thing further is this GitHub for PEASSNG. It's a privilege escalation suite for like Mac, Linux, and Unix systems, which identifies a lot of this. So if you're interested in looking further, I suggest looking into that. And are there any questions? No? Okay. Thank you.